Hello, today we're going to be rearranging arrays by sign. It's an interesting problem, so let's see what we can do. You will be given an array that contains the same number of negative and positive numbers. Your goal is to reorder or rearrange the elements of this array so that the element's sign should alternate, meaning that it should be a positive element, then a negative element, positive element, a negative element, a positive element, then a negative element, and so on. That's this part. You need to maintain the same order between elements of the same sign that exists in the original array. For example, in the given array, the 3 comes before the 1 and the 2, so the rearranged array or the result array should respect that. And finally, the easiest condition, you have to start with a positive element, and then you begin to alternate positive, negative, as we explained. So this one is clear as well. One possible solution is to separate or segregate the positive and negative numbers. For example, we can have two arrays or even queues, one for the positives and one for the negatives, and we simply start iterating over our array. The 3 is a positive number, so it goes to the positives. 1 as well. -2 is for the negatives. -5 is negative. 2 is positive. -4 is negative. And at this point, building the result array should be pretty straightforward. We need to start with a positive, so we're gonna take one element from the positive. So let's say 3. And then one from the negative to alternate. -2. Done. One from the positives. 1. Done. One from the negatives. -5. Done. One from the positives. And finally, the last element in the negatives. And after merging these two arrays, we get our solution, as proven as well here. So it's quite simple. Time and space complexity are linear, nothing fancy, and all good. But if you're looking for something more interesting, then the next question might pop up. How can I improve on this? Well, if I look at the space complexity and the queues or the arrays that I'm using, I will notice that there's nothing fancy going on here. We're not manipulating these elements anyhow, not performing any changes on them, and we're even holding them in the same order that they appeared in the original array. So the next question would be, do I really need these two? Their only goal was to segregate or differentiate between negative and positive elements in the original array, which would lead me to think, can I actually do this in my original array? When I was iterating over it, I was going one by one. So I was checking one element at a time, and one element can only be positive or negative. So I needed the array to differentiate between them. But what if I can check multiple elements at the same time? What if I can have 2 pointers, one on the positive and one on the negative? That would open a new world of possibilities for me. Both pointers will start at the beginning. Since we need a positive integer in the beginning, so I will start with a positive pointer. I will ask myself, is the positive pointer pointing to a positive number? The answer is yes, so I will do 2 things. Add this number here to the result array, and then move my pointer to here. Is it a positive number? Yes. So I will leave it for now, and then jump to my blue negative pointer. Is it pointing at the negative number? No, then I will move it to here. Is it pointing at a negative number? No, then I'll move it again. Is it pointing at a negative number? Yes, it is. So I will add this number to my result and move my pointer again to here. Is it pointing to a negative number? Yes, then I will leave it here. And the reason that I have moved it, although I have already found and added my negative number, is that when I get back to it, I don't want it to be at the same place because I don't want to recheck for -2 again. I want to avoid adding -2 twice. Of course, I can leave it here and handle it in my code. So when I'm switching between pointers, I avoid checking the element that the point is currently at and just start from the next one, which is eventually going to lead to the same thing, but I prefer this approach. You can use any. It's the same idea. Just avoid adding the same element twice. We added our negative number, switch pointers, positive pointer. Is it pointing at the positive number? Yes, it is. I can directly add it and then move my pointer. Is it now pointing at a positive number? No. Move it again. Still not positive. Move it again. Found a positive number. So I will leave my positive pointer there and pick up the negative one. As you can see, following the current approach, I can directly take this element that the negative pointer is pointing at, which is -5, and then move my negative pointer to the next negative number. Let's switch to positive again. It's pointing at the next positive number already, so I'll just add it. So it's a 2 here. What is that? Like, is that a snake? Is that a 9? Then I'm going to try to move my positive pointer, no more number, my pointer for wee, like that. Switch to the negatives. Negative pointer is at the negative number, so I can just add it, and then I hit the boundaries of my array, which means that I'm done. Managed to reach the same solution without needing two arrays, and we have taken one step closer towards making the world a better place. For our solution, we are iterating once over each element of the original array, meaning that the time complexity will be ov n, and we have ditched the two arrays. We're not using any more arrays or fancy data structures, meaning that the space complexity will be ov n.